From loose cotton fibers to finished t-shirts, every stage must control softness, strength, and shape.
This follows one typical route. Ginned cotton becomes yarn, fabric, cut panels, then a wearable shirt. Different mills combine these operations differently, but the material changes remain recognizable at each handoff clearly. The finish matters because cotton must survive repeated washing while keeping the garment comfortable and stable.
Each bale carries fibers with variation, so blending begins before a consistent yarn can be spun. Opening separates packed fiber, exposing more surface so later cleaning and alignment can work evenly. Dust extraction removes lighter contamination, protecting both yarn quality and the cleaner working environment around equipment. At this point, cotton is a cloud-like mass, not yet the orderly strand needed for fabric. An automatic feeder meters the blend, preventing sudden thick or thin patches from traveling further downstream.
Carding removes remaining short waste while combing the usable fibers into a soft, continuous web.
The web funnels through a trumpet, becoming a loose rope called sliver, ready for controlled drafting.
This drawing stage evens fiber distribution, which helps the eventual yarn feel uniform along its length. For a fine knit shirt, combing may remove more short fibers. This plant uses that option.
The combed sliver is cleaner and more parallel, trading some fiber yield for a smoother yarn.
A roving frame gently thins the strand and adds slight twist, preparing it for final spinning.
That fragile roving holds together just enough for high-speed spindles to draw it into real yarn.
Ring spinning draws the roving much finer as the spindle twist locks thousands of fibers together.
The result is thinner. Twist creates tensile strength needed for weaving, knitting, and sewing later.
Travelers circle each spindle, winding newly formed yarn evenly onto bobbins while maintaining its controlled twist. Sensors watch for breaks, because one failed strand can interrupt a bank of spindles within seconds.
Automatic winders transfer yarn onto larger cones, clearing weak sections before fabric production begins.
A yarn clearer detects abnormal thick or thin places, cutting them out before the cone continues.
The new cone has a stable winding shape, allowing yarn to unwind smoothly at higher speeds.
Small lab checks compare yarn appearance and evenness, catching issues before thousands of meters become fabric.
Accepted cones feed a circular knitting machine, where every yarn path must remain evenly tensioned. Needles rise and fall around the cylinder, looping yarn into a tube of undyed knit fabric.
Unlike weaving, knitting builds flexible interlocking loops, giving this future shirt its familiar stretch and drape.
Freshly knitted fabric is called graige goods. structurally complete but still rough, untreated, and unfinished.
The fabric tube opens into a flat width, making later washing, dyeing, inspection, and cutting possible.
Before color, scouring washes away natural waxes and processing residues so water can wet cotton evenly.
In a wet process range, the fabric moves through baths under tension, without stretching its knit loops. Bleaching, when used, brightens the base. Dyeing then replaces that neutral surface with durable color. For colored shirts, reactive dyes commonly bond with cotton under carefully controlled chemical and temperature conditions.
The wash-off stages remove unfixed dye, helping prevent color transfer after the garment is worn.
Squeezing rollers remove excess water before heated air dries the fabric without flattening its knitted character.
A stenter frame holds the edges at a set width, helping stabilize dimensions and surface appearance.
Finishing can add softness and control shrinkage, but recipes vary with fabric weight and garment feel. An inspection frame reveals faults under even light, allowing operators to isolate affected fabric before cutting. After wet processing, the fabric has become soft, colored, stable knit, ready to become garment components. The operator loads relaxed rolls for spreading, matching grain direction so each panel behaves consistently later. The finished fabric is ready for cutting. Its color, width, and stretch have already been checked. Spreading machines lay many fabric plies flat, creating a uniform stack for accurate multi-piece cutting.
A cutting marker guides the layout, nesting front, back, sleeve, and collar shapes to reduce waste. The cutter follows the marked paths through the stack, producing matched panels with clean, repeatable edges.
At sewing stations, operators join panels in sequence, using guides that keep seam allowances consistent. Overlock machines trim and wrap raw edges together, forming flexible seams that resist fraying during wear. Ribbed neckbands are stretched precisely as they are sewn, so the neckline recovers without rippling.
Side seams close the tubular body, turning separate panels into a recognizable garment with real volume. Cover stitch machines finish hems with stretch, so the edge lies flat but moves with the wearer.
A small care label is inserted where required, while inspectors watch alignment and seam cleanliness.
Quality inspection begins with appearance. Operators scan fabric, seams, hems, and neckline symmetry under bright light.
They measure key garment points against the approved specification, confirming sewing produced the required shape. Seam inspection checks skip stitches, puckering, and uneven joins, defects visible once the shirt is worn. Where factories use needle detection, finished garments pass through a final safety screen before packing. Any piece needing correction is separated for rework, rather than allowing a defect into the finished batch. This feedback loop matters. Inspection findings can trace problems back to cutting, sewing, or fabric preparation. The quality desk is the last opportunity to protect consistency before garments disappear into cartons.
Only then does a t-shirt leave production, ready for sale, transport, and everyday use.
A final steam press smooths creases and sets the garment into a consistent presentation for folding.
Folding turns the garment into a standard shipping unit, while preserving the shape proven at inspection. Workers add required generic size identifiers and protective bags, keeping the textile clean through distribution.
Palletizing consolidates many cartons into stable loads, reducing handling and protecting products through movement.
Stretch wrap holds the pallet together, while corner protection helps keep stacked cartons square and secure.
Forklifts move finished loads to dispatch lanes, separating completed garments from the factory's unfinished material flow.
At warehouse scale, the same shirt becomes inventory. Thousands of carefully repeated decisions ready to travel.
The production line ends here, but the cotton's transformation continues through stores, homes, and repeated wear.
Compressed cotton became a finished t-shirt through controlled changes in structure, color, and form.
Its softness begins with fiber selection. Its durability depends on spinning, knitting, finishing, and accurate assembly.
A satisfying rhythm hides careful engineering. Every handoff protects the material needed by the next machine. A cotton shirt carries an industrial chain from raw fiber to the garment people live in. For factory journeys from raw material to finished product, subscribe and suggest the next process below.